streaming. Let me send an announcement. Can people hear me? Can you say yes on the chat if you hear me? Great, Raya, thank you. Thanks, Dawan, Dulce, awesome, Virginia. So today I'm on the north side auditorium. I think I'm going to switch every week between the two auditoriums. But I can still hear what people type on the south side. All right. There's a student here on the north side auditorium that's, okay, Kaylee, that's right. Kaylee, you are wearing the green object. If you click on that object, right click on the object and just say take off or something, you will stop wearing it. You have to right click on the green object. There. Kelly, I don't know if you're here, if you already see me and hear me on the stream. If anybody is wearing an object that you don't want, just right click on that object and choose take off or something like that. For example, detach, that's right. Just click, right click on the object and say detach. There's another student wearing the green object. We type these instructions down. Let me see if I can. No, I cannot detach. I cannot detach it for you. You have to be the one detaching it. All right, so we are 2 minutes into the time of the lecture. Welcome to ICS 10. We'll do the lecture like this, even with people wearing strange objects. That's okay. So here's the plan of the lecture today. Some logistics. I guess it's related to people wearing unwanted objects. I don't know if anybody else has any other questions about logistics. Let me know. There's a second student wearing another object. Okay, so if you're wearing an object, right click on it and choose detach, and it should detach from you. But so the main goal of today's lecture is to walk you through the instructions for the machine. And you have the project due this weekend, I believe on Sunday. I know that some of you have already started working on it, and that's a very wise thing to do. I know that some of you probably haven't started working on it yet because I am tracking how many people have watched my tutorial videos, and there's not as many views as the number of students here. So that means that many of you haven't even started looking into the tutorial for the instructions for the machine. I strongly recommend that if you haven't started working on your project, that you do so this afternoon, because these things take a little time. For many of you, some of these things that we're going to do here in this class are very foreign. We're going to have to learn how to program in this very low-level programming language in this machine. And so the sooner you start, the better chances you have that you will be able to finish successfully. Also because the TAs have some office hours, and you should make sure that you get help from the TAs if you are stuck on something, okay? But come Saturday, the TAs are not going to be able to help you. So if you are leaving the project for Saturday, that is a very, very bad strategy, let me warn you, because maybe nobody is here to help you. All right? So today's lecture is about the instruction set, and I'm going to follow a little bit what I did for the videos, but I'm going to give more examples, and I will do also some coding on demand. If somebody wants me to to show how to do something, I will do it. So let me go. So after I give my lecture. I will. Are people hearing me? Am I appearing offline? Can people see me on Twitch on the screen? Yes? Can you type yes? Timmy? Okay, great. So, okay, awesome. All right, somebody was saying that they can see me. All right, so there is a breakout session today in the middle of the lecture in which you're going to do some bug finding exercise. But for the most part, what I want to do today is go through the instruction set and explain, how to use those instructions for, what are they good for, and how exactly you use them. So let me go here to one of the machines. I have a machine here on the north side auditorium. I will sit down. Okay, so I will start by explaining the arithmetic operations, and those are the easier ones. They are very easy to understand. So let me go here. Some arithmetic operations. So I have, for example, a program in here that you may not be able to read, but I will load into the machine and you'll be able to read there. So if I go here, this is just to explain to you how the arithmetic works. So this little program, I just read a value from the input, and then I put some constant value on another register, and I add the two registers, and then you'll see where the result is going to be. Okay, so I'm going to step carefully. So I'm going to step. This means that I need to enter some number. Let me enter the number 12, for example, enter. And then I'm going to step again. Now 12 went to the register 0. That's where I read. So the reading said reading to the register 0. That's where it is there. And now I set R1 to 4. Okay, the register 1 now has value 4. And now I'm just going to add R0 with R1. And the result is going to be always placed on the second register. In all of these operations, the results are placed in the second register of the operation. So 12 plus 4 is 16. So the resultant R1, and now if I can write it out, right? 16 writes out to the output. Okay, so this is pretty simple. All of the other arithmetic operations work in pretty much the same way. Let me explain. For example, the multiplication is virtually identical to the sum. Go back here. Let's read a number. Let's stay with 12 again. Then set R1 to 4, and now multiply one by the other. You get 48, and then it writes out. Okay, so this is pretty simple. The only things that you should know about the arithmetic operations here have to do with the division and subtraction. So let me start with the subtraction. So if I want to do a subtraction over here, let me show you. I say okay, so I read into register 0. Oops, sorry. So read into register 0, 12, why not? Then I put R1, 4. And now the way that you have to read the subtraction operation is subtract something from something. So that's the meaning of those two words. Subtract something from something. So in this case, subtract R0 from R1. And in this case, R0 is greater than R1. So we would get a negative number, right? If I subtract 12 from 4, I'm going to get -8. But this machine, the way that I design it, does not have negative numbers. It can only have 0 or positive numbers. So when it encounters a negative number, it just puts 0. Okay, so let's see what happens. When I click here, right, it's 0 because this was going to be negative, and this machine does not have negative numbers because that's a whole other can of worms. Okay, so that's the only thing to know about the subtraction is the order of the operands is that subtract something from something. And the next thing that is important to know is that if the result is negative, then it's going to be a 0, not negative, but just 0, okay? So that's one thing to have in mind. The other thing to have in mind is the divisions. So let me do the other way around. So let me divide R1 by R0 so that you see what can happen. I will go here. Okay, so I'm going to read a number, and let's do this, read 12. Then I'm going to set R1 to 4, and then I'm going to divide R1 by the number that I read. So 4 divided by 12, that's going to be 0, because again, we don't have decimal numbers in this machine. So that's going to be 0, and it's going to be placed up here because it's the last one, and that's it. Now, something that can go wrong in divisions, and I should warn you, is that if I read, let me step. So I'm going to read, but now I'm going to enter a 0, okay? Let me show you how things can go wrong. So I'm going to enter 0, okay, enter 0, and then I'm going to set R1 to 4, and I'm going to divide R1 by R0, which is 0. Okay, a division by 0 in general is an error. There's no such thing in mathematics as dividing by 0. It's undefined in mathematics. So the way that computers usually deal with that is by giving an error. And if you see what's going to happen here, I'm going to step, and there's an error that's going to show up here that there has been an attempt dividing by 0. Okay, I don't know if when you're running this you are going to see it, or if I'm the only one who sees it because I'm the owner of these machines, but it's just to let you know that this can happen. Okay, that means that you attempted to divide something by 0. And I just realized that somebody clicked on the program memory over here and erased my program. That's okay, I was done with it anyway. So those are the arithmetic instructions, how to do and the other thing that all right, so another one that is also important is the module operator. So the module is actually a very good thing for you to know. It's the reminder. Let me show you what it does. Let me put this back again, R0 by R1. Okay, so I'm going to read a number. Let me go back to 12. I'm going to set the register 1 to 4. And now I'm going to say the module R0 by R1. So the modulo operator is the division, but what you get is not the result, the integer result, it's the reminder of the revision. So in this case, I'm dividing 12 by 4. It's an integer number of times, so we're going to have 0 as the reminder. But if I entered something else, let me start. If I entered, for example, 13, okay, and I'm going to set it to 4, and I'm going to divide 13 by 4. 4 goes into 13 3 times, and the remainder is 1. So the remainder should be 1 there. The reminder is an important operation in computers in general because many times you have to break a big number into smaller numbers, and that is done usually by division. But then it's not just the division, the integer part that you need to work with, but you also need to work with the remainder of the division operation. Okay, so the remainder, and you will see some things coming up next week when we talk about data representations. So the modulo operator is an important arithmetic operation here. Okay, does anybody want me to cover anything about the arithmetic operations? These are pretty simple. Okay, if nobody needs me to cover anything, let me move on. I'm going to move on the set of operations that is the memory operations. So these are the operations that the CPU uses to store values in the memory and to get values from the memory back to the registers. So let me start by one over here. For example, I'm going to read, and then I'm going to read, put it in memory, and then retrieve from memory. So put it in memory, fetch 0 to R2. Let's see what this does. Okay, it looks like people are having some trouble getting connected to Twitch right now. Hold on, let me just send a message. I don't know if Twitch is failing again to give connections to people. Let me just say here. Okay. All right, so let me continue to the memory operation. So the first memory operation that I'm going to explain is the following. I'm going to read a number from the input, then I'm going to store that number on memory location 0, and then I'm going to fetch from that memory location and put it on another register R2. Okay, it's just to show you how the mechanics of these things work. So I'm going to step in, read a number 13. I'm going to store R0, which is the number that I just read, into memory location 0. Okay, there it is, 13. And now I'm going to fetch. Fetch means read, get. So fetch memory location 0 and put it on R2. Okay, so there. So why is this important? So why is memory important? It's important because in some of the programs that you are going to do, um, having three registers is not enough to hold the data that you need to hold on to. Okay, so the registers are just to make additions and subtractions, but then the results of those things, the registers are not enough. You need to offload those values somewhere and store them somewhere. So that's when you do some calculation and then you store the result in memory. And then when you need it, you go into the memory and fetch it back again to do some other operation. Okay, so that's how we use the memory. So there's these direct manipulations where you say store some register into a certain location and you give the location exactly here. Um, and then there's also a indirect addressing. Let me show you how that works. That's with the stars. So let me say, for example, here, I'll write it first and then I explain. Set R1 to, I don't know, 8. And then say star star R0 in R1. And then I say fetch star R1, R2. I'll first read this and then I'll explain what this means, what this does. So this one, I'm going to read a number and then I'm going to do the following. I want to put a number in memory, okay? But instead of giving the address directly in the program, I'm going to put the address in a register and then I'm going to say store that value that I want in that memory location that is in some other register. Okay, so let me show you how this goes. So I am going to, so Bevan has a good question. Can we directly add two numbers in a memory? No, you can't. And in fact, this is in computers you also can't. So in computers, if you have memories, the memory is just to store things, right? If you want to have some operation, you have to go and bring those values into the CPU, actually to the ALU, the arithmetic and logic unit. And it's only that component that does all the operations. So you cannot do operations directly in memory. Okay, so we're doing this here to emulate exactly what computers do. There's no such thing as doing operations directly in memory. There's this extra thing of bringing it into the registers, and that's where you do the operations. Okay, so let me step into here, read. Okay, read 13, and I'm going to set register 1 to 8. All right. And now what this means, the next thing that I'm going to say is store star, okay, this is the indirect store, R1, the value of R0 into the memory location that it's pointed to in R1. Okay, so look what happens when I step, what's happening here is that I'm storing 13 on this memory location down here, which is memory location 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay? And now the next one is fetching. So I'm fetching star, means I'm fetching indirectly from the memory location pointed to by R1 and place the value in R2. Okay, so if I step in here, I went to that location over there and put it here. So why is this interesting? Why is this important? Why is it important that we are able to do right? So Nicola is asking, what does the star do? So the star is to distinguish from the operation without the star. The star means that it's the indirect form. So in the direct form, we have store some register and then we give it the exact location. So we give it a number, like in exactly. It means 0.2 by R1. Exactly. So without the star, it means it's a direct addressing. It means store R0 in memory location 8, for example, and you give it the number 8. But with the star, you don't give it a number, you give it a register. And what that means is that you're going to store in the location that is in register, in this case, R1. Okay? So it's an indirect addressing. You first need to look into what's in here, and then this means that this is the address where you want to store. All right? And again, why is this important? Because in many times in some programs that you want to write, you don't like you don't necessarily want to put to hard code exactly the memory location 1, memory location 2, memory location 3. You don't want to hard code it. What you want is to have those addresses also be part of the program. So for example, if you want to fill out 10 positions of the memory with the same number, for example, instead of having 10 instructions, do this, do this, do this, what you're going to have is you're going to have a little increment. Instead of me talking here, let me show you. Let me set some R0 to a value, some value, whatever, 3. And now I'm going to do the following thing. I'm going to set R1 to 8. Let me write it and then I explain what I'm doing. And now I'm going to say star R0 R1. And then I'm going to say the following thing. Set R2 1, and I'm going to subtract R2 from R1. So let me do the following thing over here. I'm going to star I'm going to store R1 in location 13, for example. I'm going to store, then I'm going to set, I'm going to subtract, and then I'm going to, after I subtract, I store R1 in, oops, somebody's doing stuff on their machines. No, I don't need to do this. I'm sorry. I don't need to do this. Subtract, and then I am going to jump if not 0, 0, 1, 2 to line 2. So I'm going to set some value here. I'm going to set this to 8, and then I'm going to store the number 3 on position 8. Then I'm going to subtract 1 from 8, so it's going to be 7. And then then it goes back again over here, storing 0, 1, 2. Okay, this should work. Let me show you what this does. So first I will do it, and then I'll explain what this does. So I'm going to set R0 to some number 3, whatever. Okay, and then I'm going to set the register 1 to 8. It's going to be a memory location. Now I'm going to say to store the number 3 on that memory location. Okay, there it is, the number 3. And now I'm going to set R2 to 1 and subtract R1 from R1. So that's going to be 7. And now I'm going to jump again, and I'm jumping ahead literally to the branching operations. But basically, I'm to jump to line number 2. Okay, and what this is going to do? Oh, sorry. I have a bug. It's not this. It's jump R1. There you go. I had a little there. Okay, so let's start 3. I put this 8. I'm going to store 3 on memory location 8. I'm going to subtract 1, so that's it, and I'm going to jump again. Okay, and I'm going to store the same value 3, but this time on position 7 because I subtracted 1. Right, so there it is. So basically, I'm filling out the first 8 or so positions in memory. Let me run this without me interacting. So I'm going to basically fill out a few 8 or so positions in memory with the same number, right? Without having a separate instruction for each one of them. So it's a much smaller program, and I'm just decrementing the address, automatically, right? So it ends when it reaches the end, and so this is an example of why this operation indirect addressing is important, because the memory location itself may be an important part of the program that you are writing. Okay. So, and this brings me to the branching operations, which are indeed the most, probably the most unusual and the most foreign to many of you who have never done programming. So, what is branching? So, branching is this idea that, as you see, you have this little red pointer that goes from line to line, right? And if you have a program without branching, the way that it goes, it starts on line number 0 and it just continues until it reaches the end of the program, right? So that's sort of a normal simple program that does not have any jumps. But sometimes we want to do something many times, right? We want to repeat something many times. And if we want to repeat something many times, we don't want to have a program that, is basically copy paste of the same thing those many times, right? That's a little bit super annoying, because then you may have a bug and then you have to fix the bug in all of those different repetitions. So what people have come up with this idea that in the program you can have instructions that tell the CPU to go back to a certain line of code that you already did before. So those are called the branching operations, and there are many flavors of branching operations. There's branching unconditionally, you just say go to line whatever. And then there's what's called conditional branching, which is if something is 0 or if something is not 0, then go to some line. All right. So this is what branching is. So let me start here with I'm going to explain. Let me start with this very simple program. I'm going to, for example, read reading some number, all right, and then I'm going to say jump to line 0, 1, 2, 3. I'll hold on into the label here. So now I'm going to say set R1 to 3 or whatever, 4, and I'm going to say add R0 to R1, and I'm going to say let me do the other way around, R1 to R0, and then I'm going to just write out R0. So I'm going to read, and then I'm going to just jump to line 0, 1, 2, 3, 4. 4, okay? So let me show you what this does. This is a silly example that just shows the mechanics of unconditional jumps. All right, so I'm going to read a number, 13, why not? And then I'm going to jump. Means that I skip all those, those middle lines, I skip them all, and I just jump to the line 4, right? I didn't test anything, I just jumped to line 4. Okay, this is what's called an unconditional jump, which is useful, but it's not as useful as the conditional jumps. The conditional jumps are more useful because those you can test, if something is some value or not of some value, then you go to one line, otherwise you go to another line. So let me show you an example of those conditional jumps. Here's one example. This is an example of a jump if not 0, I believe. Let me jump if not 0. So I'm going to set R2 to 3, R1 to 1, and then I'm going to read the value to R0. I'm going to subtract right, so this one, I'll show you what this does. This one is going to read a fixed 3 values, okay, exactly 3 values from the input. Let me show you how this works. So I'm going to step in here. This one sets the R2 to 3, sets R1 to 1 to prepare 2 for the subtraction, okay? You'll see what's going on. Then I'm going to read a number, okay? Read a number, I'm not doing anything with the number, I'm just reading it. Now I'm going to subtract R1 from R2, okay? So now R2 is going to be 2, all right? And then I'm going to test jump if not 0. So while it's not 0, I'm going to jump to line 2. Basically, I'm going to read another number, okay? So it's not 0, so it's going to jump to line 2. And that's going to make it read another number and read again, right? So I read again, it's not doing anything with the number, but now it's going to subtract again, okay? So now R2 is 1, and it's still not 0, so it reads again, okay? So it reads again for the third time, and now it's going to subtract again from R2, and this time it's 0. So if it's 0, it's not going to jump back. It's going to continue, okay? And this mechanics over here, it's a mechanics that is very important for your projects, for a project this week that is due this week. Because in your project, you are being asked to read up to 8 numbers from the input. And moreover, if the input is 0, then you should stop reading. Okay, so there's two branches that are going on. One that tests that you have this on the loop that reads at most 8 values from the input, and then another one that tests if the input is 0, then you get out of that loop and you continue to do whatever it is that your program is doing, the maximum or the average or whatever. Okay, so bear in mind these mechanics that I just explained of the jump, if setting a register to a certain number that's going to be counting the number of times that you do something, right? And then you set another register to decrement, it's going to subtract 1 every time. And then at some point you test if you finally reached 0. And when we finally reach 0, then you know that you did that the number of times that you wanted to do, and you should not do more of those, okay? So branching is a really cool thing, and we are going to see them. This is sort of the bread and butter of programming as we move along. We'll see in different flavors as we move up the level of abstraction of the programming language. But this is how it looks like underneath at the assembly level, the kinds of machine instructions. It's basically you do some arithmetic operation and then you test if the result was 0 or not 0, and then you jump into different lines depending on whether it was 0 or not 0. Okay? So is every week's project going to be coding? No. So there's a question here if every week's project is going to be coding. Using this machine. No, there's going to be, for example, the next project that you're going to do, it's a mixture. There will be one small program that I'm going to give you, sort of one program that does almost the thing that you need to do, and you just need to change it to do something just slightly different. But most important, that's just 1/3 of the project. The other 2/3 are another kinds of machines that I'm going to place on your tree houses. It's not going to be programming. It's just going to be direct manipulation of some tiles. So not every project is going to involve coding in this low-level machine. And in fact, as we move along the quarter, we are going to move away from this machine and moving into more higher level programming abstractions, okay? Any more questions about this? Branching, ask me. Branching, let me tell you, if you've never programmed, like many of you, I saw the statistics of I asked you some information about you, and many of you here, at least half of you, have never programmed before. So the branching may be the sort of the weirdest thing here that you're going to have to grasp. Okay, another question. Is there a specific data set of numbers you wanted us to use, or is this fine? I don't know what this refers to, but so in your projects, there's two things that you need to do. One is the average. So you need to write a program that accepts many numbers from the input up to 8. Okay, and then it should output the average. So if you enter 10, 11, 12, the average should be 11, right? And you need to to make the calculations to calculate the average of those numbers. And so you need to write a program that accepts many inputs up to 8. But if the person enters a 0, then it means that stop. I don't want to enter more numbers. Stop that. So there's another question. For the Fibonacci, yeah, for the Fibonacci, that's right. For the Fibonacci, which is the third program that you need to write, you don't need to be on a loop. You just say the input is just some number, 14, and your output should in the output you should be flashing the 14 first numbers in the Fibonacci sequence, right? So you first 0, 1, then 1, then 2, then 3, then 5, 8, 13, etc. Okay, up to, so in the Fibonacci there's only one input, not many. More questions? All right, so if there are no more questions, let me tell you what I have in mind for the breakout. Let me stand up. I want you to go to your treehouse, but before you go, you take something. As usual, I want you to take something from here and place it on your treehouse so that I can see that you have been doing the in-class exercises. So this time there is this object over here. These objects, the pink objects, there's one on each side of the stage in both auditoriums. So stand up and get a copy. So basically what that means, okay, I'm sorry, there's another question over here from Brendan. How do we have the computer flash out the numbers for the Fibonacci sequence? So it's just with write outs, okay? So we just write out the next number, okay? And this is slow enough that you will see each one, at a time. Okay, so to get a copy of this object, right click on it and then more, and then take copy, okay? So right click, more, take copy. And that will place a copy of this in your inventory. This thing is called 2021-01-21 in class exercises. It should go into an objects folder. So it should go somewhere in the objects, in your objects folder over here. There should be a copy of this if you take it successfully. That's called 2021-01-21. So before you go into a treehouse, please listen to what I have to say. So once you have this in your inventory, you go to your treehouse, you put it on the lawn. So again, putting on the lawn is just grabbing from the inventory and putting it, just dragging it to the lawn. But then there's still more things that you need to do. Once it's on your lawn and it's your object, you right click on your object on the lawn again, and then you say open, and then you say copy to inventory. Okay, so this will give you 3 files that's going to be placed in a folder called 2021-01-21. All right, and there's an instruction notebook in there. Okay, so open that instructions and you'll see what you have to do. Okay, so here's another thing that let me just do it the whole thing myself here. So go here, more, take copy. Okay, so there should be under objects, there should be a copy of the object. Once you go into your treehouse, just drag it onto the floor. All right, and once you drag it onto the floor, right click again and then open and then copy to inventory. Okay, and this should give you these 3 files, and one of them is the instructions of what you need to do. There's 3 things that you need to do. There's basically a program, a program that is almost right but not quite. There's some bug, and your goal is to find where the bug is. Okay, So if you want to talk to me while you are in your treehouse, let me start a group chat. You all probably are in the group called Builders. So I'm going to tell you how to talk with everybody. Let me start the chat here. Builders. Hopefully this will work. Maybe? No? I need to activate my group. Let me see here. Okay, maybe the group chat is not working. Anyway, so to right click on this right object, or this pink object, both to take a copy and then to grab the contents and do the exercise. Okay, I will send a message to everybody when I want you to come back. Okay.